Hello everyone, in this session we will study linked list. So before starting linked list, let us first discuss about arrays. So till now, if you want to store data, then arrays and variables are the two ways that we know. But there is a problem with arrays. Now the problem with arrays is basically it has fixed size. For example, if my array is of size 5, then I cannot insert the sixth element. So consider this array. So the array is of size 5 and let's say the elements are 1, 2, 3, 4 and 5 and these are the indexes 0, 1, 2, 3 and 4. Now let's say I want to add two more elements. Then the problem with the arrays is basically the elements are stored continuously. So if its address is 100, then its address will be 104, then 108, then 112 and 116. So if we want to store two more elements, let's say the elements are 6 and 7, then what will happen? So basically its address should be 120 and the address of this memory location should be 124 because the elements in array are stored continuously. But there is no guarantee that these two memory locations are basically free. So there is no guarantee that this memory is free. It may be occupied by some other process. So that means we cannot extend the size of our array. Now the one solution is basically what we can do. We can use a dynamic array that we have already studied. Now the second solution of this array problem is basically using linked list. So let us discuss how we can solve this problem of arrays with the help of linked list. So the array problem is basically due to the continuous allocation of the memory. Now what linked list says do random allocation of memory. So in linked list we will have random allocation of memory. So let us take one example. So suppose you have four elements 1, 2, 3 and 4. These are the four elements that you want to store. So how we can use linked list? So basically this is my first element. Let's say its memory address is 100. This is my second element 2, and let's say its memory address is 200. This is my third element. Let's say address is 320, and this is my fourth element. Let's say address is 480. So there is random allocation of memory. Okay, you can see the addresses, these are random. So we are doing random allocation of memory. Then what we will do? So 1 will point towards the next element, 2 will point towards its next element, and similarly 3 will point towards the next element, which is element 4. And what we will do? So we will store this address in a variable. We will store address 100 in a variable. Now what we are doing here? So we are doing random allocation of memory, and basically you can see, so this is a link. So there is a link and this is very similar to a list. So that's why it is called linked list. Okay, so that's why it is called linked list. Now in linked list, if we are doing random allocation, that means we can add as much number of elements as we want. Okay, so now how can we access the elements of a linked list? So in array what happens? So if this is your array, now let's say there are 4 elements only. So if you want to access the elements of an array, what we will do? So basically we will store the address of the first element. We will store the address of the first element, which is basically the name of the array itself. And then what we can do? So since there is continuous allocation of memory, so we can do something like this: star of a plus I, or basically we can write a of I, where I is the index. So this is how we can access the elements of an array. But how we can access the elements of a linked list? Now it is very simple. What we will do? We will just need to store the memory address of the first element. Let's see how. So what we will do? So suppose I have 4 elements. This is my first element, second element, third element and fourth element. And let's say the addresses are 100. Let's say 200, 320 and let's say 480. So this is element 1, element 2, element 3 and element 4. Now what we will do, each node, so I am calling it a node. Similarly, this is also a node, this is also a node, and this one is also a node. So what we will do, each node will store the address of the next node. So this is 200, so each node will store the address of the next node. So it will store 200. The address of this node is 320, so this node will store 320. I am repeating myself, each node will store the address of the next node. Similarly, the address of this node is 480, so 480 will come here. And for the last node, so for the last node there is no next node, so I will store null here. Okay, so we are storing null here because there is no next node. Then what we will do, we will store the address of the first node. So what I will do, I will store the address 100. Okay, now if you want to iterate, what you will do, so print the content present at address 100, so I will print 1. Then what I will do, so here is 20, so go to memory address 20 and print its content. Then I will print 2. Then it is storing 320, so go to 320 and print the content. Then I will print 3. Then it is containing address 480, so go to memory address 480 and print the content. So I will print 4. Now it is containing memory address null. So null means stop. So null means I will stop, and this is my output. This is my output. So basically what is happening here is each node is pointing towards the next node. So 200, each node is pointing towards the next node. Its memory address is 200, so that's why it is pointing towards the next node. Similarly, this node will point towards this node, and this node is going to point towards this node. So this pointing, basically it only helps us in understanding. Actually we are doing this only. This link does not exist, but for the sake of understanding we can assume there is a link. Okay, so this is only for understanding. Actually we will store data in this manner only. I will store the data, so this is my data, and this is actually a pointer. Why pointer? Because we are storing the address, so that's why a pointer. Now this is not a data type. So basically what we will do, we will create a class with the name node. So let's see what we will do. So I am going to create a class, and the name of the class is node. Now you can see yourself, each node is containing two things. First one is the data, and the second one is basically a pointer. So first one is a data, int data, and this is a pointer, so it will be a pointer, so star. Then let's say the name is next. Let's say the name is next because it is storing the address of the next node. Okay, so for example, I have an integer int a is 5. Now I want to store the address of a. So what I will do, star b is address of a. Now what will be the data type? So data type will be the data type of a. So a is integer, so I will write integer here. Now what is this next containing? So this is my next. Now next is containing the address of the next node. It is containing the address of the next node, so that's why the data type will be node here. Node star next. Simple. So this will be the structure of the node. It will contain two things, data and the next pointer. Simple. Okay, so enough of theory. Let's just write the code and see how it is working. So I have this file linklist.cpp. So we are going to create a class with the name node. So class node, and for now let us assume everything is public. So first one is the data, and the second one is actually a pointer. So node star next. Again, why this is node here? Because it is containing the address of the next node. So node star next. And now let us also create the constructor. Now the constructor is taking data as input. And next is null. Initially next is null. Okay, so our class node is ready. Now how can we create objects? So basically we know there are two ways of creating object. One is statically and one is dynamically. So for now let us create objects statically. So I am creating objects statically. So what is the syntax? Node n1. So is this right? No, this is not right, because as soon as we create our parameterized constructor, default constructor is not available. So this line is going to call the default constructor, and default constructor is not there, so it will give us error. So let us call the parameterized constructor. Let us pass the data. So node n1. Now let us create one more node. So node n2, and let's say the data is 2. So what is happening at this line is basically, so what is happening here, as soon as you write this line, what will happen? So this constructor will be called. So basically you will get a node. This is a node. The data is 1, you can see, and the next is containing null. So this is containing null. Now at this line what will happen? You will get one more node. So the name of this node is n1 and the name of this node is n2. The data you passed is 2 actually, so 2, and the next is containing null. So it is null here. Now what we have to do, so basically I have told you that each node will store the address of the next node. So if this is my linked list, 1 is pointing towards 2, then what will happen? So ideally, instead of null, what will happen? The address of n2 should be here. So if this address is 100 and let's say the address is 200, so I have to replace null by 200. So basically what I will write, so address of n2 is equals to n1 dot next. So after writing this line, n1 dot next is the address of n2. So address of n2 is 200. So this null will be replaced by 200, and basically our linked list will look something like this. Okay, so this arrow is actually only for understanding purpose. The data is stored in this manner only, but for the sake of understanding, we can assume the linked list is something like this. We can visualize it like this: 1, 2. Then if you want to add one more node, then we will do something like this. If you want to add one more node, then we will do something like this. So basically, the first, if this is my linked list, then the first node, we call it the head. This is the head of the linked list, and the last node, we call it tail. Okay, so the first node is called head, and the name of the last node is actually tail. Simple. So currently we have only two nodes. So that means n1 node is actually the head of my linked list, and n2 node is actually the tail of my linked list. Okay, so to make this connection, 1 arrow 2, I have to do this. Okay, so let's do this. Now to make the connection, what I have to do, so n1 dot next, it will store the address of the next node, and the next node is actually n2 only. Simple. Okay, so if you want to print the data, so how can we print the data? So for printing the data, we can do something like this: n1 dot data, and similarly we can print the data of the n2 node. So n2 dot data. So let's run our program and see. Okay, so this is the data of n1 node, and this is the data of n2 node, 1 and 2. Simple. Okay, so I told you currently we have only two nodes, n1 node and n2 node. So what we will do, I am going to create a pointer head. Now what this head pointer will do, it will store the address of the first node, and this is the first node, n1. So it will store the address of the first node. Now this is a pointer, so that's why star will come here, and n1 is of type node, so node will come here. So node star head is actually containing the address of n1 node. Okay, so let's do this. So what we'll do here, I am creating a pointer node star head, and it will store the address of the first node, and the first node is n1 only. Okay, n1. So what is happening? So what is happening here? So at this line, what will happen? Basically, you will get a node. The data is 1 and the next pointer is containing null. Let's say the address is 100 and the name of this node is n1. At this line, what will happen? You will get another node. Let's say the data is 2. The address is 200. The name of the node is n2 and the next pointer is null. Okay, so you can see next is containing null. Then at this line, what you are doing, so the address of n2 will be stored in the next variable. So address of n2, so what you will do, this null will be replaced by 200. Simple. Now we are printing the content, so 1 will get printed, then 2 will get printed. Simple. 1 here and 2 here. Now what we are doing, so node star head is containing the address of the first node. So at this line, we are not creating any new node. So this is basically, we will get 8 bytes of memory because a pointer is of 8 bytes. The name of this variable is head and it is storing so this is 100. So 100 will be present here. Okay. So at this line, we are not creating any new node. We will just get 8 bytes of memory and the name of this variable is head and it is containing 100. 100 basically is the address of the first node. Simple. Now I want to print the content of the linked list with the help of head. So I want to print 1 with the help of head. So what I will write, so I will write something like this: head arrow next. Sorry, head arrow data. So if I will try to print head arrow data, then my output will be 1. Okay, so head arrow data is same as star head dot data. This is just a short way to write. Okay, so star head means dereference. So go to memory address 100. So go to memory address 100 and then print the data. So data is 1. So I will print 1. So if I will do head arrow data, then 1 will get printed. Simple. So let's see. So if I will do head arrow data, then the output should be 1. So let's see. Okay, so the output is 1. Now in the next video, we will discuss how to print the data of n2 node with the help of this head pointer. Okay, so I'm repeating myself. In the next video, we will see how can we print the data of n2 node with the help of head pointer. So I will see you in the next one. Bye bye.